Thanks for the introduction and thanks for your patience. So I have the honor to present joint work together with Jan Tostorff, who is also here today, Hannes Federath and Luigi Loiacono, and it's about internet users' perceptions of disclosing biometric data in order to improve the security of their online accounts. And so the technical thing behind this is continuous authentication, a novel authentication scheme. And the difference to traditional authentication schemes is that usually when we log into an online service, we do it at a single point of time, at the entry point. So when logging into a service using certain authentication schemes like password-based or multi-factor-based authentication, and then we get an authenticated session that can last quite long. Especially in a mobile context, the session can be nearly infinitively long, because usually we log into an app while we install the app, and then the session runs until we get a new phone. So, of course, that session is secured by the device authentication scheme on the mobile device, but if an attacker gains access to that device, overcomes the authentication scheme, then he has access to all of the authenticated sessions that are running on the device. And to mitigate that, especially the scientific community proposed to introduce a continuous authentication. And a continuous authentication is operating after the entry point authentication and observing all biometrics, or observing biometrics that occur while interacting with a device or an application in order to estimate whether the current user is the legitimate one or an attacker. So it's based on analyzing biometric data, and that biometric data is very diverse, as you can see here. These all have been proposed to be used for continuous authentication systems. So the first one from the psychological group are more like the traditional biometrics we all know, and maybe also use them already in entry point authentication systems. But there are also behavioral biometrics like the keystrokes dynamics, for example. But all that share that they are biometric data. Of course, that's why they are quite sensitive, and that's why they are also considered to be sensitive by certain privacy laws, which require special actions to take place when process such data. So this research is, in essence, about weighting up disclosing that sensitive biometric data in order to get more account security. And we are especially interested in two questions here. And the first one is, do users differentiate between different biometrics when waiting up to disclose them in order to gain more account security? And the second is, what's the influence of the online service that is to be secured with disclosing those biometric data? So to research that, we performed an online survey that included at the end 830 valid participants from the US. And we told them that by disclosing different types of biometric traits, they could improve the security of an online account. So we showed them 15 different types of biometrics and asked them to rate their willingness to disclose those in order to improve their account security. And we performed that in an between subject design. So we had 7 conditions that are framed by different types of online services that are to be secured with that biometric traits. So quickly, some of the results. First, we asked them to rate 15 different biometrics, and it's a lot of data, and there's a lot of statistics, and it gets very complicated. So we thought, okay, do they really differentiate between 15 different types of biometrics, or do they use another concept? So we tried to find groups of biometrics that are kind of rated the same by our participants. So we put all the ratings of willingness to disclose those biometrics together and ran a factorial analysis, and that revealed that, in essence, there are 4 underlying factors that affected the ratings of that 15 different types of biometrics. And so we took a look on the biometrics that are listed under these factors, trying to find an explanation for that, and we concluded that it's something to do with the origin of the biometrics. So, for example, here the first group are all biometrics that occur while interacting with a device, while the second group contains all profiling-like related biometric data. The third group, the body-related one, are more like the traditional psychological biometrics we know from traditional authentication systems. And then the last group contains the medical biometrics, the biopotential ones. So now we took those 4 groups for the further analysis, and especially to answer the question whether our participants differentiated between those biometrics when it comes to disclosing them in order to improve the account security. And here is a diagram of the absolute ratings and willingness to disclose those biometrics, separated by the groups we've identified on the slides before, and of course also with the different online service contexts, which are not relevant for that slide now, that's because they're gray. But we see overall a tendency that our participants preferred to disclose the device interaction biometrics over the profiling and body-related ones, and that they definitely don't want to disclose biopotential biometrics in order to improve their online account security. So we see that they rate the biometrics differently, and we can also see at this picture that they make differences between the online service that is to be secured. So let's take a look at that and add some color to the diagram. So not all of the differences we see here are really significant, but some are, and some are quite interesting. For example, the first one here, we found that in a video streaming context, our participants significantly were less willingness to disclose biometrics from the device interaction group. Second interesting thing was for the social media context, they were less willing to disclose profiling related biometrics. And another interesting thing here is that for the banking and payment conditions, or for banking and payment online services, they are significantly more willing to disclose those body-related biometrics like face recognition and fingerprint than for all other types of online services. So we see that both the type of biometric and the context of online service has an impact on the willingness to disclose, and some of you might also already have an idea on why those, for example, 3 highlighted things occurred in the ratings. But of course we were also interested in that, and we evaluated which factors could influence our participants' willingness to disclose. So we performed a structural model and ran multiple PLSMs. And we included 2 types of constructs in there. On the left side, you see constructs that are related to the online service provider that is to be secured. And on the right side, we see the constructs that are specific to a certain type of biometric trait. And we found that neither the risk that is related to the asset, to lose an asset due to an attack, or the susceptibility of that incident plays a role when it comes to deciding whether to disclose or not a biometric trait. But we found a very, very few significant paths for the trust in the provider, but only in a few conditions. But a lot more that shows that there is a negative impact of the general risks that are associated with disclosing biometric data to a service provider for continuous authentication. However, for all biometric traits and all survey conditions, we found a negative impact of privacy risk related to disclosing biometric data, and a strong positive impact of the response efficacy that our participants perceived. So, summarizing, we found that users differentiate between 4 groups of biometric data to be used for continuous authentication, and that they generally prefer to disclose device interaction traits. And we found that their willingness to disclose biometric data for continuous authentication is mainly influenced by biometric-specific privacy risks and the response efficacy, and also by a service provider-specific risk that occurs when they disclose biometric data. So how can we use our results in future work? Our results help in selecting the appropriate biometrics for future continuous authentication systems, because now we know which types of biometrics are preferred by the users for which types of online services. Especially the groups of traits we've identified that group many different biometrics help to perform privacy impact assessment for continuous authentication systems, as it's, for example, foreseen in the GDPR, that we also should respect our users' perspectives. And lastly, the results even help to design architectures for continuous authentication systems, because we have seen that the risk related to a provider plays a role in our participants' ratings. So if we find an architecture that reduces that risk, then we can hopefully also improve the overall acceptance of continuous authentication systems. So that was a quick overview. If you're interested in more, of course, you can read our paper or ask questions now or later at the conference. Thank you very much.
Okay, thank you very much for the talk. Any questions from audience? Yes, please.
I would be curious about the granularity of your data that you collected. I totally understand that you grouped the things together, because that was also a very lovely visualization that you made. But did you collect the individual level of information? Let's say that for the social media, people are less willing to share their location, while more willing to actually use the device statistics. Because despite that the groups make a lot of sense, some of these things are much more privacy intrusive in individual groups than others. So do you have that level of data? Is it in the paper?
Yes, so for all survey conditions, we ask people to rate 15 different biometrics. So we asked them to rate the 15 levels of willingness to disclose, 15 levels of response efficacy, and 15 levels of privacy risk. So we have that granulated data, and it's also available as an artifact to our paper.
Any other questions? Oh, yes.
Yeah, thanks for the presentation. So my question, did you also look, or are you planning to look into the difference between continuous authentication and single authentication in terms of a user's willingness to share data?
Of course, we looked into that by trying to compare our results with past work. But of course, the big difference is that most of the traits we investigated here in the context of continuous authentication don't work for static authentication. Because, for example, the profiling-based ones, they can't be used at a single point of time. That's why we don't have that results in earlier works on static authentication. But in general, when we compare the biometric authentication thing with the traditional biometric authentication and the continuous authentication, we found that for the traditional authentication, users tend to prefer that body-related biometrics like fingerprint and face recognition that, of course, they know from other systems, over the, for example, device authentication biometrics. And that's, I guess, mainly because of that influence of the response efficacy we've seen before. So if users don't think that it helps that we use their device interaction biometrics for a single time login system, then they are not willing to provide those data. Thank you.
I think we can take one more question. Okay, yes.
Thank you for the interesting talk. I would like to ask that, did you find that the behavior of users' willingness to disclose their biometrics is somehow related with their concern of the security of the biometrics, how they will be like secured, kept secured or like that?
Good question. So we haven't asked that specifically about the security, but I think that's in the constructs of, for example, risk related to disclosing a biometric trait to a service provider. So that's not specifically security, but we asked them whether they think it is risky to disclose their biometric data to the service provider. And I think if they have security fears when disclosing biometric data, then they would see a bigger risk there. So I guess that we kind of have that information respected in the data, even though we haven't explicitly asked them. Because the problem, of course, is we don't have that system where we could say that's the security of the system, or where we can expect that users can somehow estimate whether there's a risk or not, because it's so abstract for now.
Okay, thank you.
Thank you.